So I'm going to step over the Godot C++ code with the debugger and just try to understand the camera orbit. I'm gonna put 2 hours, then I'm gonna take a break. I'm probably gonna stop streaming after 2 hours and then take a break off stream and then come back after. I'm probably gonna have to disable these breakpoints because I think that they are running on every frame. So yeah. I wanna see if I can open the editor and then do the, because it seems that the orbit function is not running on every frame here because I have a breakpoint there is not showing. So I wanna see if I can try to move the editor, the visualization of the editor, to see if the debugger is gonna stop on that function. But I'm pretty sure that this is supposed to be the function that converts the cursor into the camera and is gonna update the visualization, which is the function that I was trying to translate. That I tried to translate yesterday and it didn't work, so I'm not sure if it's not working because, and maybe it is working, it's just different, but it it, it feels that it's different for sure. So on my thing there, my implementation of the camera, it seems that the camera moves, and on Godot's implementation, it seems that the visualization moves and the camera stays on the same place. And on Godot's implementation, it seems that the camera is moving around the thing. But it might be because of the grid that Godot has on the as a like a platform for the stuff that is showing there and the axis. Then it becomes easier to see the movement. So it might be the same thing, but I'm gonna try to put the camera on the same place, let's say, that I usually do on the game there to see if it is different. But I'm pretty sure it is different. And this stuff, if I try to copy everything that they do, I'm just gonna replace this editor settings with the actual value that they have. Because on the game, obviously, you don't have the editor. You can compile the engine so that's, yeah, I can change the module there so that it requires to have editor stuff, but I don't wanna do that. So if I do copy the stuff that they have, I'm just gonna hard code the values of this because this macro here gets the value from the settings on the editor. So it seems that they are doing linear interpolation between the old value and the new value and getting the minimum. So yeah, between the old and the new, and they get the minimum value to do the interpolation from. So assume the last value here on the function is the value of t, which determines the ratio of interpolation, I think. But it's gonna be 0. It's gonna be 1. No, it's gonna be 0 because it's the minimum. Actually, this is kind of weird because it's division by 0. Fuck. I don't know why that doesn't throw an error there. Yeah, so this runs every frame. So this must be so the notification function, and I talked about this on other streams. The notification function on the nodes is a function that is a virtual function that is declared as a macro that is part of the object class. So any class that uses this GD class here macro is gonna implement this notification function, and it is a function that is called at certain points in the cycle, the rendering cycle, to on every node that inherits from object, I think. And it's gonna run the process. It's gonna call this function on the process parts of the cycle if you put set process equals true. So you have to set the process, the number variable, I think, from the object class equals to true. And then it makes it call the function for the class. So it's basically a function that runs for the entire class hierarchy. It's basically this function here, which is a virtual function. So if you want to change the behavior of the class hierarchy, you implement this function. And by default, it's not going to be reversed. So it's going to call from the base of the class hierarchy. So the object is usually the base of all the classes. So the object calls its implementation of the notification function, which probably is going to emit. I'm not really sure if it doesn't do anything or if it emits the signal equivalent to that notification. So in the same time that it calls the notification function, it also emits the signal. And the signal is the GDScript version of the thing. So when you declare or when you define a function on the GDScript from Godot's editor, it's basically gonna do the same thing here. So at the same moment that it's calling the notification for the object class is gonna emit the signal for the script. It's gonna emit the signal which is gonna make the script call the function if you have the function defined on the class. So, and the process part of the cycle runs every frame. So that's why I think that is off by default almost, and you have to manually turn on. But it looks like here is calling this. So, and this one is gonna update the camera. So it makes me think that is more common sense that this function here is gonna be the one that converts the cursor that they have on this class here. So this class is inherits from control, I think. Control is the base node for GUI elements. And they have this cursor struct and then a member variable of the cursor struct type that update the information for the movements of the camera. There's also these ones that I didn't see because I think they're not directly related to the events. The one that is related is the cursor, which is this one. And this struct here holds the state, which is basically these things here. And this is the comment that I was talking about. The one may be interpolated, the one defined, blah, blah. Viewport camera supports movements moving, so one cursor is the real cursor while the other can be an interpolated version. So the camera cursor is the interpolated and the cursor is the immediate one. So they use this cursor here to update the values based on whatever's happening on the visualization. And then they probably translate the cursor here on the update function. I think that's what's going on here. I don't think that makes sense because this is the... So this function is going to run at different parts of the cycle, like I said. And what determines the difference is basically what is passed as an argument. So each one of these here is the equivalent of what's happening on GDScript. So notification ready, I think, happens when the node is ready. There's another event that is node enter tree. So I think that's the first one that runs. Or there's another event when the node is added as a child. So maybe that's the first one. Then after that is enter tree. Then you have the ready, which is probably after this shoe. And you have the process, which happens on the May iteration. And you have the physics process, which happens here. So physics process happens when this function is called. So the main iteration is the main function that does everything on the iteration, like the name says. So after they set everything up, this function is gonna update everything from the engine. And it's gonna call all these functions from the entire scene tree for each node. And it's gonna update the physics and call the rendering server, I think, to draw stuff. And this is after everything has been set up already. So first it runs the physics process, which is going to call the notification function for each node, passing the physics process event, which you're going to put there on the switch. And then you can define whatever, you can call whatever function you want to change the behavior of the node. And the other one is the process, which happens here. So this is gonna traverse the sync tree, which is the main tree of the entire application, I think. And for each node, it calls the process and it emits the signals for the events. So this should run every frame. I'm not sure if there's more that run every frame, but I'm 100% sure that the notification process and the notification physics process. I don't remember really well if it's physics process, but as the notification related to the physics, those two are the main ones that run every time. And usually you implement stuff there when you want the behavior of the node to change every frame, or to be based on whatever. I think on GDScript I've seen people do stuff with the camera from GDScript on the process parts. But this is, I think, this is less ideal. So probably the way that they are doing there is the best way, which is that because there are two other main functions. One is GUI input. But GUI input, I'm not 100% sure, but I think GUI input runs for every node that inherits from control, because control is the GUI elements. And it's basically the same logic from the notification, where if you want to define behavior that happens after an event, GUI input is going to be a virtual function, so you redeclare it, let's say, and you declare it on the class that inherited from the control nodes, and then on that function you can specify whatever is going to happen on the event, which is basically what I'm doing here. Yeah, so For nodes that don't inherit from the control, you can redefine the input, or you can specify the input on the class that inherits from node 3D or node. I think the input's defined on the node class and is a virtual function. So you can specify here whatever you want to happen after an event. And I think that's the main difference. So like this function is only gonna run if there is an event, and the process function runs every frame regardless. So I think a combination of the two is probably the best, which are what they're doing there. So you listen for events on these functions here, and then on the process you update the camera probably. But maybe you can get away with just doing, I'm gonna try to do it like this and not update with the delta like they are doing there. Hey, what's up? So this one I remember based on, I think was when I was studying the export functionality. I think, yeah. Yeah, it was when I was studying the exports and the saving scene functionality. So this edited scene routes is basically how they manage the root of the current scene on the editor. And it is kind of confusing there, but it's like basically, I don't remember if it's, I know for sure that there's a class that is a member variable of the editor class, but I think that it's from a member of that class. So there's a class that is a member from the editor, and a member from that class is the one that has the vector that is going to keep track of the edited scenes. And then they get the edited scenes by index, I think. So this here is most likely, obviously, the root of the current scene, and then they're getting the camera from the root of the current scene. So they get the viewports, and then they get the camera 3D from the viewports. Yeah, so I think that it makes the most sense to be this function here. The one that's gonna translate the cursor information from this class into the camera there. So I'm trying to, someone's asking what is this about. I'm trying to recreate this. So it's kind of a long story, but basically I'm trying, let me think about this. So like since I started learning how to code, I wanted to create something to visualize the connection between files on the code. So like in the very beginning, I did something with Python that someone helped me when they on string. That's to create a graph of dependencies, for example. And then from that point, I've been trying to create something that allows me to visualize the connection. And that's basically what I did here. So I participated in something called Nights and Weekends from BuildSpace. It's a program where you have to build something from scratch in 6 weeks. That's basically what I did. I think on 2 different versions. So I had to learn 3JS, React Fiber, and all this stuff. and I was trying to create on the front end. And the thing that I didn't like about this is that it takes, like React gets too much in the way because you have to update the state of the website and everything. And because you're doing everything on JavaScript and you have to update the state with React, because React is the easiest one that I found to work. I tested other libraries as well, but they had different problems. So I managed to make this work and with 3JS, but then I decided that it's probably better to do it from try to do it from C++ because then I can remove everything that doesn't make sense. And that's what I'm trying to do. So in the beginning, I was trying to create everything from scratch without any engine because I didn't understand the line of what is the responsibility of a game engine. It wasn't clear to me. So, and also because I wanted to learn the fundamentals better. So learn from first principles. And then I found this website here that is very useful. It's called Scratch a Pixel. They basically teach everything about fundamentals. I highly recommend this for everyone that wants to learn stuff. But then I was making everything from scratch until I got to the point where I was able to draw text to the screen. I learned the billboarding stuff, texture coordinates, and how to do everything like the camera movements, everything. First I tried with Raylib, then I tried from scratch, and then after that I realized, as I learned more about game engines and stuff like that, I realized that it's probably better to just use Godot because they know everything that, they went through all the challenges and they know better probably. So then I started to study Godot, and that's what I'm doing now, basically. So I'm trying to change, right now I'm changing the Godot source code so I can implement the stuff that I need there. But the goal is to reproduce this stuff here. Have another, but this one is basically just simple functionality that I was doing as a kind of like an idea of what I'm trying to do in the beginning here. I'm not really sure if I'm going to change this. I'm probably going to change and do something else, but here is just basically representing the logic of the OR gate with the connections here. And then I have this other one that I did, which is like just a file, parsing, getting the abstract syntax tree from a Python file, and then highlighting the connections of the nodes of the abstract syntax tree. But it's very slow. And then I have this component here that allows you to change the physics, which I basically got from VJS. And then I studied how VJS does it, and then I changed so that it worked with 3JS. So this is the main file, pandas generate version. This is the file that the graph is from. And then the connections highlight some connection of the nodes on the abstract syntax tree that makes up the file. Abstract syntax tree is a part of the compilation process. So when you have a compiler, you're basically going to take one string as inputs, and then you're going to output another string that is going to serve as a intermediate representation between it's basically assembly language that it makes the connection with the hardware, which is a standard that people create. So that's all the compiler is. You just take the file as a massive string, and then you separate the file into Lexer tokens, which are basically the words of the language. And then you create a tree that represents the meaning of the words by the connection of the tree. Then depending which kind of parser you have, you're gonna traverse the tree in order to derive the meaning from the keywords of the language. And the connection of the tree is the grammar rules that make up the meaning, which makes up the sentence. And after you traverse the tree, you're gonna have, I didn't study that part too much, but basically you're gonna do a control flow. In some situations, you do a control flow graph to take the meaning that you get and distribute the work for different registers, depending what kind of architecture you have. But basically, you create, from the meaning, you create an intermediate representation, which is like a kind of like an assembly language that is just determined by the instruction set architecture from the hardware that the OS is going to use to communicate with the hardware in order to allocate the memory from the registers and to do whatever your code wants to do. So, yeah. So right now I'm trying to understand how the editor does the orbit from the camera, so that I can uh, I can try to implement in the way that I do there in the game that I have. Not the game, but the application that I'm trying to build. But like the way that I'm doing, it seems to be the same, but it feels different. So I want to understand why. But if I spend too much time on this and I can't do it, then I'm just gonna move on to something else. I have a list there of steps that I'm following. Oh, thank you, man. It's basically these steps here. And also, I have another list that I made of a bunch of stuff that I have to study as well to understand more the mathematics about how basically it's topology, I think, the main field of the study of shapes. Topology and algebraic calculus or something like that. It's basically this playlist that I'm watching now, algebraic topology. And there's a bunch of other stuff as well. Discrete geometry as well, which is basically the study of procedural mesh generation, which is just taking dividing a topological space into triangles so you can render them on the GPU. And it gets pretty complicated, I think. But right now I have the like fundamental. I created the Bezier curve on 3D. I finally managed to create. Maybe there's some stuff. There's probably some stuff that I can improve. The other thing that I realized is that I can put other functions there or just change the type. So do the same functions but with a different type, and then the curve will work for 2D as well. But yeah, I have the curves, then I have the nodes from Godot, and I have the labels. So all that is left to do is just to figure out how to set up the environment in Godot so it looks similar to this, and then I start creating I already have the class for creating the graph. And the other thing that I need is to figure out the camera. I think those are the two main things. And then figure out the Barnstead solver, which is a solver that I'm using here, which is probably the best solver that I found to visualize this kind of stuff. But I'm not really sure if I'm gonna like do the same. I'm probably gonna change what I'm doing here. But that's the general direction that I think I'm gonna go. I'm gonna be right back. I have to go to the bathroom. I think this is another thing that runs every frame because it's gonna be parts of the update camera, I think. And this is a function that I copied last time and it didn't work, but it might be because of the way that's this values here. Interesting. So the first time that I saw this was 0 there. It's gonna hmm. So I'm gonna write down these values. Wonder if I can copy. I'm pretty sure I still have there. Um, so let me copy here. The problem to me is that it doesn't make sense here. I don't understand why would this work. But it seems that this is the way that they are doing there. Minus P equals X rotation. So you translate. So usually based on the other tutorials that I've seen, like the distance is the same before and after you rotate. So you translate to a point that is going to be a distance from the camera. You translate the camera to the points you want to visualize, then you rotate the camera, and then you translate outside. It's like you're getting very close to the thing, and then you're doing the rotation, and then you're zooming out. So based on the tutorials that I've seen, the distance has to be the same. It just has to be inverted. So like if this is a vector of 0, 0, and minus 10, for example, here, then here would be 10, 0, 0, 10. It's just the opposite of this vector here. And minus on the framework that Godot uses, I believe the minus is to this minus on the z direction is to move into the scene, and positive is to move outside. And also the other thing that I saw from the documentation there is that apparently Godot uses clockwise winding order for the front face of the geometry. I think that's the reason why I had to change the order of the indexes or of the indices that I used there to create the curve. Because again, from 3JS probably uses counterclockwise. So based on the documentation, and I'm not really sure, it wasn't really related to that, I think, but it was something related to the camera, and I'm pretty sure that I ran that there. But it might be the case that it's just for some situations that it renders clockwise, but I think it's probably all of them. And it renders the winding order is going to be clockwise, which means that the order in which you put the vertices or the indices for the vertices is going to determine what Godot considers should be the front of the geometry in the back. And usually by default, no, by default on Godot, it's only going to render the front. So if you put the indices in a counterclockwise order, then it's not going to show the geometry. It's only going to show the back of the geometry. I should write down the values as well. and put these values here instead, just to see what's gonna happen. Oh, I forgot to, yeah, whatever, last time. Can go here. And the problem is that's not gonna highlight there. So next time that I'm going over this, I'm just gonna disable these breakpoints. It might be this function here, the one that I'm missing. I think this is the one that I was spending time yesterday. But I think this one is more for the grid that Godot puts there, and also the thing for showing the coordinates. I think this is what this is about here. So it is related to the camera, so it gets the distance from the camera, from the plane of the camera to the plane of the grid that is gonna put there, and then does some calculations for updating the scale of the grid, probably, like it is here. But I don't think it's directly related to the camera, so it's not the stuff that I'm looking for. Like, this is not the stuff that is gonna change the... I'm pretty sure that the thing that changes is the one that I'm seeing there. It's just gonna be the update camera function. So it takes the values of the cursor, and then it changes them. It converts them into the camera matrix on that function. So I'm gonna press the 5. It's probably gonna stop on the... Yeah, this one, so... So press the 5 again. The biggest problem with this is that I'm not gonna be able to see there. But, I was gonna say, maybe I will still do this. So after I check for the event there, if I can do that, then once it hits the breakpoint, then I can put these ones back on again to see what's gonna happen with these ones after it updates the values of the cursor. I mainly focus on the orbit because I think that's the one that is more incorrect. The other ones are probably... I did the right way there, I think. Because it's not that hard. You just get the delta for the mouse movement for the panning. Then you translate the camera based on translate on the XY based on the mouse movement, the camera position. And for the zooming, you just change the value of the Z for the camera, so which is called dolly. Scratch a pixel, they say that you should call that dolly, because zooming is when you change the focal length, which is the angle that makes up the illusion of projection, because you're basically creating a pyramid from the perspective of the viewer, which is outside of the screen. And then, at least for the way that I think about it now, whatever shows up on the screen is called the near plane, and the projection is on the far plane, which creates this shape where the top of the pyramid is on where the viewer is at, which is behind the screen. So what determines how close or outside how further or near, I'm not sure how to say that in English, but how close things are from the camera is basically the angle of the projection. So that's called the field of view, and which is related to the focus, I think. So when you want to actually zoom in and out, what you do is just change the angle, which makes the pyramid either wider or shorter, or yeah, shorter, I think. Wider or like, I don't know how to say that, but lower length, I guess. And that makes things zoom in and out. But this kind of zooming changes the resolution, which I think is more complicated to do. So I think what people usually do is just change the Z of the camera and they keep the same thing. So what's actually happening is that the camera is getting closer. So I think you press shift and then press down the wheel and then rotate. Yeah. So this, so I'm probably gonna have to remove. No, I think, yeah, actually I did the wrong. Shift and the wheel is to pan, and then only the pressing the wheel and then moving the mouse is to rotate. But I wanna see this one as well. So P relative, if I remember, is gonna be is basically just getting the relative position for the mouse, which is what I'm doing here. So you cast the events. So on this function that you define on the class that inherits from node, the inputs are an abstract virtual, I think it's just virtual function from the node. So you define on the class that you want to change the behavior on the inputs. Then this function is going to receive this generic input here, which is a reference class from Godot, which I have to study more in depth to understand, but it's basically doing garbage collection on C++. So they implemented garbage collection through this class here, which is a ref, and usually use this class for resources. So whatever type you put here as a template when you initialize the class is going to be the type that the ref class is keeping track of. So it just keeps track of how many references the thing has, and it makes it easier to delete and create memory based on the references. So you receive the event and then you cast like this. So this function is going to be called for all kinds of events, and then you determine what kind of event it is by reassigning to a variable and changing the type based on the ref. And then you use this function to check to see if the type is valid. If it is, it means that that's currently the event being run. And then you put whatever functionality you want here. And the way you get the type of the event that happens whenever this event, input event mouse button happen, is basically on the switch statement here. You call this function to get the index of the event. And then you put these different cases here. So this is for scrolling the wheel up and down. Based on other tutorials that I've seen, usually people just put flag variables here to determine that the event happened, and they put the actual functionality on the input event mouse motion, which is the event that tracks the motion of the mouse. But this is also used for a wheel as well. So for determining when the wheel changes. So usually people just put these flag variables here to determine that the event happened. And then on the input event mouse motion is where they actually implement the functionality for the event. And this one has the get position, which I think is the absolute position. This is the screen position of the mouse, which you have, if you want to change here, you have to convert to 3D coordinates. And the way that they allow you to do this is by putting this project position, which I think comes from the Camera 3D. So Camera 3D allows you to call this function called project position, which is going to convert the screen coordinates of the mouse position into camera world coordinates, I think. I'm not sure if it's world coordinates. I'm pretty sure that's what makes the most sense, but it might be local coordinates for the position, but I think it's world coordinates. And then you can do stuff here, but I changed this, so now I'm only translating by the scale. Just this one. And for the input event mouse motion, you can use this get relative here from the event. And this allows you to get the delta. So the difference between the last position of the mouse and the current position. which makes it so that it doesn't matter the coordinates, because obviously on the delta you're going to subtract one position by the other, so the coordinate becomes irrelevant, I think. And usually that's what people do anyway, so I think that's why they did it like this. Because the usual way to do it, I think, is you set the... So this is when the mouse is down, let's say, for the panning, for example. So when you click the mouse, you put a flag variable that determines that the event happened, and then you assign another value here that gets the position. So you would use this one, for example, keep track of the position here. And then on this one, you would get the position of that moment, and then you would subtract the two to get the delta. And at the end, you would update the position as well, where the event happened last time, so that you update the... So you just get the constant delta, let's say. But they implemented this already, I think, here on the get relative, which already gets the delta, which I'm pretty sure is going to be this value here. So this is already the value of the delta, and that's why it's 1 and 0 here, one of the x. And yeah, so they're basically... It's weird that this has the rotate as well. Maybe I should change the way that I'm doing my stuff. So this is going to be the position of where the event happens, probably. No, this is the current cursor position. I think this is the last position that the thing was at. Interesting. So I guess one thing that I can try to do is just do the same thing that they are doing there. Just copy the cursor struct to the class that I have there, then create this cursor and then do exactly the same thing that they're doing. That might be a good idea. So I have to see where they initialize this, but I'm pretty sure... I think I've seen all the places that have the equal, like they do the assignment to these values here, and they all happen inside of events. It might happen on other classes, that's the problem, but I can start with 0, I think. So initialize everything with 0, and then just do the same thing that they do here. But I think what's happening here is that they are translating the camera. So this is... Transform 2D is a class that has, I think, a 4x4 matrix, and is composed of a basis matrix, which is a 3x3. So it's a basis class that represents a 3x3 matrix, and then there's a vector, vector 3, which is the origin of position. And that's how they do the transformations. So the transform 3D is basically a 4x4 matrix that represents the camera local state, I think. So the translate local, if I remember, or if I remember correctly from the documentation, the translate local translates the coordinates of the transform 2D on the local reference frame, which is not the world reference frame. So to go from the local to the world, I think you have to multiply by the inverse of the parent matrix, if the thing has any parents. Or you get the inverse of the camera, something like that. And then you multiply with the projection matrix, and that gives you the world coordinates. So when you're translating locally, you're just translating according to the reference frame of the thing itself. Just translate, I think it's just updating the transform, this transform here to represent the position of the last position that the camera was at, which is tracked with the cursor position. I think that's what's happening. And then it rotates the basis, which is the 3x3 matrix that is going to keep track of the states of this transform 3D, based on the rotation that the cursor had as well. The thing that I don't understand very well is why do they use this cursor instead of using the camera directly. So this is the thing that is kind of weird to me. It might be because of the way that they did things there, where it makes more sense to create something outside of the main thing that you're using to visualize in order to change the state. And then it makes it easier to update the thing that you're using to visualize. So the translate the transform with the... So I think this is basically updating the state of this camera transform to reflect the state of the camera based on the whatever the cursor state is. And then they're just translating the camera based on this, which is the mouse movements. This represents the position relative to the delta for the x and y. and the X is inverted. It depends on the configuration of the editor, I think. So let me see. So they're both false. So it's gonna be X inverted and Y not inverted. Yeah, I think that's the best thing to do, just to make sure that I'm not doing anything wrong. I'm just gonna see if I can copy everything that they do there to see if it's gonna fix the rotation. The other difference in the way that they're doing, I think, is that thing as well that I just talked about, where they just set flag variables on the input mouse button, which is checking to see if the mouse or the wheel was pressed, and then they update the state on the mouse motion. So that might be what I have to do there. So change, but the only thing that I'm updating the state is the wheel on the mouse button. So the rotation and the panning, I'm doing the function that is gonna actually change the states on the mouse motion. So it's gonna be minus x times span speed. 0, 0. I'm gonna try to get from there. What's the band speed? And then they translate local. And maybe you should copy everything there. I'm gonna copy this stuff. Let me. I'm gonna copy everything that they do and just change the function that I have there. See what happens. So here, that's the thing. They are updating the cursor position. And so they indirectly update the camera through the cursor. That's the thing that is kind of confusing to understand. And I think it happens on the update camera function there that I was looking. So the origin represents the position, the vector tree from the transform 3D. It represents the position of the camera, and the other is the state. I think the basis is the state of the camera. I think that's another thing that I didn't. So I'm just gonna copy this stuff. I'm gonna open another thing so it doesn't get confusing. Sure. Let me copy everything. The only thing that I'm gonna change is just hard code the values instead of making it based on the values that they have there on the editor settings. I'm gonna create the cursor position as well, I think. I'm gonna try to do everything the way that they do it. See if it's gonna work. Because then it's gonna be easier to know if it's something else that I'm doing wrong there or what's going on. 0. Let me put. So this is another thing that I have to see. Yeah, so they do this here, and I think all the other ones are going to be the same. It just changes the switch there. But this one, I'm pretty sure. Oh, they also use. Yeah, this is a function that I just simplified, but it's gonna fall into this thing here. I can put a breakpoint here, but I think for all of them, it's just gonna go on this one because this is gonna return false. Warp mouse panning. So yeah, it's just easier to use. It's basically the same function that I'm using there on the mouse motion, which gets the delta for the mouse. But this is gonna happen on the mouse motion. And then on the other mouse button, they have the other switch here. There's gonna just set what kind of event it is, I think. But they also call some function, pretty sure. I can put, I'm gonna put breakpoints here as well. So the mouse button middle is the wheel when you press the wheel. The left is when you click on the left click of the thing. But I don't think there is anything directly. It's just updating stuff related to the coordinates that they have there to make it easier to visualize, I think. And other stuff that is not directly related to the camera. Yeah. But I'm gonna put the breakpoint there anyway to see what happens. This is zoom in and out. It's basically, the zoom I copied the function that they have here. Just basically gonna be this one. So the zoom they do make it on the thing as well. So I think this part is not probably what I'm doing wrong there. But I'm gonna copy the way that they do it here, so I can change. Was the way that I was doing. So I'm just translating the camera based on the. So this gets the vector that is the origin, which is basically what they're doing here, the last line here. But I'm doing directly on the camera, and then I'm getting the z factor to determine. So like when you zoom in, when you zoom out, the panning gets a lot slower. So I try to make based on the how far the camera is. So the further it is, the faster the panning gets, so that it keeps like constant speed. It's not perfect, obviously, but it's good enough. But I'm gonna try to do it on the same way that they do it there. So yeah, the first thing that I have to do is just create this cursor. I'm gonna copy there. So we're just gonna put the same stuff here. Struct cursor. And I'm gonna have to see what values they have there. I'm just gonna do this. Because the behavior that they have there on the editor is very good, and it's basically what I want. The only difference on the way that I'm doing is just gonna be what kind of, at least if I can make this happen, is gonna be what mouse inputs determine which kind of event it is. But the movement's basically the same thing that I want. This one is gonna be false for both of them. So I don't need to put. And this is gonna be basically this. What I can do is, outside of this, after I call this function, is just call the same function that they do there. So the update camera, I'm gonna try to do that, I think. So I just call these functions. So there are two things that I need to do. So one is figure out where do they initialize the values of the cursor for the first time. And before I do that, I have to copy the cursor struct from their class, so it is the same. Then figure out where the initialized values for the first time, and then copy the date camera function, so it runs after right after the events. But I think it's probably better to just do it the same way that, like, the biggest difference from the way that they are doing and the way that I'm doing here is just that they are in that class that they define there is inheriting from a control node, and my class is inheriting from camera 2D. But I pretty much I can do the same thing. So they are updating the camera on the process, I think, of the class. So I think I'm just gonna do that. So basically try to copy everything, because then like it's gonna reduce the probability that I make a mistake there. And then if that works, then I can try to think about why the other way doesn't work. Because I think that the only thing that makes sense for me right now is that the reason why all these other ways that I tried here that don't work, and the way that they are doing that works, is basically because of the way that they implement the matrices. So it's something that is happening on the way that I update here that is different than the way that they update there. And this might be the reason why you need to update stuff on the process, on the notification function of the class, and on the process. It has to run every frame. It might be this. But I'm gonna delete all this stuff here. So this was, yeah, it was actually the last one that I tested and was working was this one. It translates. It wasn't here. It translates by -15, then you rotate on X and Y based on the angles, the polar angles, and then you translate again to get close, then you rotate the camera, then you go outside. And then you orthonormalize to correct smaller inaccuracies that happen if you rotate the camera a bunch of times. So I'm gonna leave this commented out here. This is polar coordinates, but I'm pretty sure I can remember this because I wrote down there. Or maybe I should keep this here. I'm gonna remove this, I think. This one's the Quartino implementation from Scratch a Pixel. This is, I think, the simplest one, but I'm just gonna delete as well. Yeah, I'm just gonna copy the way that they do it there. This makes more sense. So let me delete everything, fuck it. I'm just gonna copy anyway. The only one that I'm gonna leave is this one. And then I'll remember what each thing is. Yeah, so here, pretty sure that I copied. So on this one, I'm probably gonna implement the same functions. I'm gonna implement in the exact same way that they are doing there. So they implement the notification function, and they put the update camera function inside of the notification process. So on this one, I need to set. I'm already setting here. So whenever you want the node to run the notification when is on the process part of the cycle, you need to put this function here to set the process to true. And this is when you want the input function to run, you need to put set process inputs. So if you don't put this to true here, then it's not going to run the input function whenever there's an input on the class, so you have to set it. And this one is for shortcuts as well. Yeah, so now let me continue this thing here. What I have to do before is copy the cursor. Oh, so yeah, it's on the initialization that. So they don't assign there anywhere. So the struct is already initialized with the default values, and then the events update the values here. And I assume that they probably have, yeah, I'm pretty sure, I know for sure that they cache the configurations of whatever happens on the editor, they keep track of the state on a file on the project based on the control flow that I've seen from when I was studying other stuff. But they basically put the editor settings or the state of the editor, they cache on the file every time they change a thing. So that's how I think that they get where the camera was at on the previous time that you saved the scene. Every time you save the scene, it's gonna save the editor state as well. So you probably guess these values from the editor state if you changed. If you don't, these are gonna be the default. So I'm gonna leave it like this for the stuff that I have here to see if it works first. And so now all I have to do is figure out is just copy the functions that they use to just basically gonna be the input functions, then create the notification here. I'm gonna do exactly the same way that they do it for all of them. So let me continue with the thing there. Maybe I should erase everything. Probably not. I'm gonna leave it like this because the time that the events happen changes. So I'll be right back. This stuff happens when the event's over already, so I don't think it's gonna do anything here. It's probably the way that I was thinking about there is gonna. It calls the GUI input here after. So GUI inputs the events for the control nodes. Yeah, so the most productive thing to do is to copy the events there. So I already copied the penning, I think. Pretty sure the penning is right, but obviously I can try multiple times until it works. So yeah, the zoom and the I have to copy the zoom and the orbiting. Then once I copy those, I can copy the update camera and then see what happens. But yeah, it's gonna be different because like they are using the camera from the viewports from the main edited scene. So like there's two different ways to go about it, obviously. One is just change the class that I have there so that it inherits from control nodes, and then I do exactly the same thing. Or I can just change the functions so that instead of calling from the camera, I just call without anything, because then like the class that I have there is already inheriting from camera 3D. But I wonder if it's better to do it the way that they are doing here. I'm gonna try it with the way that I have there first. Like probably they made it like this because they have this class is also responsible for managing the state of the grid that they have and the coordinates, the thing that shows the coordinates. So I think that's the reason why they are inheriting from control instead of camera 3D. The main idea that I have there that I'm trying to do is just create another class. I create a class that is basically the same as camera 3D, but it already comes with the default events. There's just zoom panning and orbiting. So I don't have to think about this stuff anymore. So, but I'm not really sure. I don't think it makes that much of a difference which class it inherits from. Because the main thing that is going to change. But maybe it does. I don't know. I'm going to try with the camera to inheriting from camera to D first. And here is going to be basically the same thing. And so here it seems that it's getting from here. Interesting. So I'm going to press 5. I'm going to do, if I can, I'm going to do the zoom first. That's the problem. So I have to remove this. Let me see which one is getting. So interesting. It's getting this one instead. I guess I can try with both of them. And it's also casting a different type here. So I think the main difference between this and vector 2 is that this one's gonna have width and height here. So a union is for when you wanna allocate memory for only one of these types. So it can either be a Y or a height. Or X and width. I'm gonna leave the way that I have there. So I'm gonna remove this thing. I'm just gonna leave in the way that I have there. And then if I test things and then it doesn't work, then I'll try this. I'll try to put the other way there. Oh, the other thing that I learned based on this stuff is that there is an option there when you click on the perspective, which is on the left top on the visualization, on the parts of the editor that is related to the visualization. Have a button that you can click there that is called perspective. And on that button, you can change from wireframe to display normal. Wireframe is going to show the actual triangles that the mesh has. And there's another option. I think I'm pretty sure that is on that in the same spot there that allows you to change the default behavior of penning and orbiting. So when you click that, you don't need to press shift, I think shift and press the wheel to pan. When you put the wheel, it's gonna pan automatically. So in these values, like this control flow here is related to this. And there's some other parts, but it's basically the same thing. It's just gonna change based on the editor settings, what kind of behavior it is. So this is the parts I was saying. So I'm gonna copy this stuff there. So it is 0.25 here. Just gonna yeah, 0.25. I'm just gonna simplify. This else as well. Yeah, I think this other stuff don't matter. This is gonna be some other thing related to the state of other stuff. So yeah, I think this is just updating the state of the view menu, which is what's gonna show there, I think. Yeah, what shows on the default text on the editor on the left. It should be pretty much it, I think. for the orbits. So now the only thing that I have left is the zoom. I guess I can manually look there on the function. And then after this is gonna be the update camera. So let me change as well. I think the zoom factor then need to change. Yeah. Oh, it's the other one here. As well now. Oh, I think this I can't really now remember because I'm doing here. I think here. Maybe if I change, because the reason why I did it like that in the way that it is there is because of the mouse position. So the zoom that I was doing required the mouse position. But maybe if I do it this way, then it doesn't matter. Because they're only updating the distance here. Oh, maybe this one I should comment it out because if it doesn't work, it's gonna be. Yeah, but actually, I'm just gonna remove because I think it's just better. So the reason why I did it like this is so that it updates, it zooms based on the mouse position. So the camera goes to the direction that the mouse is located. So it's changing all directions, X, Y, and Z. But usually, I think that the way that people implement zoom is just is actually a dolly to just change the position of the camera based on the Z direction, which is what I'm doing here now. After I change, so I don't think I need this stuff here. I'm just gonna try to do it the same way that usually people do it because I think it's good enough. I'm gonna remove this to simplify. Point sites. Yeah, so this should be correct. Just changing the value of the distance from the cursor. And now I have to change the... Oh, fuck. Forgot. I didn't save the last position. I have to change the signature, or yeah, signature of the function. Just remove the relative mouse position, or the mouse position. Rotate scale. Oh, it should be. So now I think I have all of them. So I did here. So this one changes the position of the cursor based on the distance from the they create here. This one changes the rotation. I think this is correct. It's the same thing that they're doing there. And the other one changes the zoom, which is the distance. So now the only thing left is the update camera, I think. So obviously, I don't know if the update camera is the same. It's the only function that they're using to translate the values of the cursor into the camera 3D, but also I already have the notification here. So I'm gonna press the 5 much times. Yeah. So let me see. I'm just gonna put. It's better. It's easier to just put there again. Oh, so they update the state of the process on this notification. Maybe this one is also. This one. So it passes the delta there. I'm gonna copy the ones that I think that are the ones that I'm probably gonna use. I think this one is just obviously gonna be related to the state of the navigation controls that I have there somewhere. That I'm probably not gonna use. I think whether or not you inherit from control node or camera 3D is gonna depend on this stuff here, because on my situation there, I'm probably gonna have to. I was thinking about this as well. Like I couldn't try to implement the orbiting of the camera based on the objects, so do the same thing that I was doing on 3GS, which is just. And I'm pretty sure that there is a way to do that, and I'm gonna have to search this way eventually, probably, which is get all the nodes that are part of the scene, and then based on that, you loop over the nodes based on the camera events, and you go over all the nodes, and then you do some transformation for them. And I think I'm gonna have to do something similar to this. But I do remember that the difference between, I don't know which one is which, but I know that there's a difference that Godot implements by default a similar logic to the one that you have on the front end, which is that whether or not you bubble events. So basically on the front end, whenever an event happens on the browser, it cascades down from the top of the tree, which is the outermost DOM element, let's say. I think the most outer element is probably the body. So the event goes from the top until the point where the event actually happens. So it traverses down the tree until that point, and then it's gonna go up the tree again based on whatever the DOM element is a part of. And if you don't put the stop propagation on the events, on any part of the tree hierarchy, then it's going to go all the way up. But if you put stop propagation, then the event stops at whatever you put stop propagation on. So the other elements are not going to be triggered when the event happens. So when you have mouse move or a click, for example, it allows you to stop the events on that element should interfere with the other events. If that makes sense. And I think here is like that by default. But I don't remember which one is which. But I think that on the inputs event, if other elements of the scene had an input event and they set a value which would be similar to stop propagation on their ends, then this event doesn't happen. So I think that's for that reason I might not have to get the objects on the scene, because for example, each time that you click on a node, if you don't want the camera to pan when you select a node, for example, you can put on the functionality, on the input functionality of the node class to stop the event from propagating. So that is not gonna trigger the event here. But I'm not 100% sure about this, so. Oh, also based on the documentation, it seems that like the transform 2D, no, the basis class. So it's gonna work based on the axis, obviously. So the basis is made up out of three vector tree. The first one represents the x-axis, the second one the y, and the third one the z-axis. And I think that they usually recommend to do transformations by creating another basis 3D or basis class and then composing different bases based on that. So yeah, the other way to think about it, which is the way that I think usually people do it, is that the camera is going to be three different axes, obviously, which is its own coordinate system. So one axis is the up, the other one is the right, and the other one is the forward. The forward vector is where the camera is pointing at, which is the z-axis. The right vector is the x-axis, and the up vector is going to be the y-axis. And that's usually how people compose the camera. And then because it makes it easier, you can use a lookat function, for example. The lookat is you get a distance from the camera on the z-axis, which is the forward. Then you do the cross product of that with the unit vector, I think, of the y direction to get the x vector. And I think that I don't remember if you do the cross product again to get. Probably you do the cross product again between the x and the z to get the up, and then you're able to get the three coordinates of the camera. And with that, you shift the camera to look at an object, for example. So it's very similar to the way that Fernet frames work. It's basically the same logic. Or if you as long as you have these three different vectors, it allows you to create your own coordinate system. So it's basically based on this logic I think that they do most of the operations here. So that's probably why it's called forward here. And then right, it's basically the same thing. And I think the X form is basically to do that. I don't, like I said many times, I don't like the X form name because it's kind of confusing, but I think that's basically what it's doing, probably. But the X form, if I remember, it does the dot product, not the cross product, and there's just ups to that thing. So maybe it's a different transformation, but so it's multiplying, it's doing the X form from the x-axis, and then it says that this is the right of the vector. So maybe the X form. So when you do the X form on the axis, you're just gonna get the direction from the axis, the vector that represents the direction of the axis. So the camera transform is the 4x4 matrix. The basis is the 3x3 matrix, which represents the state of the camera. And when you call X form on that and you pass the x-axis, it allows you to get the right vector from the camera. Because the right vector is the vector that represents the x direction. So just the value. So that's what it's doing. And it's basically doing the dot product on each axis by the vector you pass there. And so because you're passing the x vector, you're just gonna, when you do the dot product on the other rows, it's probably gonna make them 0. It's only because the only one that is gonna be 1 is the x-axis, so the other ones become null, and you get the magnitude because it's gonna be on each row. If there were transformations that were done on the matrix, then the transformations are gonna be stored on the axis, on the x-axis for each row. So it's just gonna get the sum of them, I think, or like the ending result for each place, I think. Because dot product's just gonna be multiplying the vector for each column, I think. If the vector is considered to be a row, then multiplies by the column, and vice versa. Gets the up the same way. So I think this is just updating the navigation with the keys. Interesting. This direction, motion times speed. There's delta. Yeah, now I'm not really sure if I should put this or not. I think I'm just gonna comment it out and then put only the update camera. Because I think this is related to the... Yeah, I can see the values there, obviously. But it's gonna be related to the movement on the keyboard, based on the whatever input map you have, I think. So it's basically getting the forward, right, and up vector of the camera, and then it's updating based on the input map states. Is updating the direction based on the input map, and then uses that based on the input map speed that you have there. And this delta, which probably comes from the physics, like from the frame, yeah. Delta, I think, is the calculation for like how much time has passed between frames. So it's basically changing the cursor position by the motion, which is the multiplication of the direction speed and delta. Is the change in direction in relationship to the frames. So let me see. I'm just gonna go over. Yeah, so it doesn't do anything. I think I'm not gonna put this. No. It's probably not related to the... It is related, but it's for when you're moving the camera with the keyboard, I think. The different kind of events. This one, I'm just gonna copy. So I'm just gonna copy the entire function. And then I'm gonna simplify based on the stuff there. Oh, that should be public, I think. Now, the only difference is that, so here is not going to be orthogonal, so I think I can just delete whatever. So this is going to be true, so I'm going to remove. And that's the only condition that it uses, so it has this one. Yeah, I don't think I need to do this stuff. That's the thing that is kind of weird. I don't need to set the perspective of the camera. So I'm gonna comment this stuff out. This one I think I do need though. Problem is that this changes the camera cursor and not the cursor. There's other stuff also I think I can comment it out. I think I can leave this like it is here. It's basically just using. Oh no, this is the only one that's. So I'm gonna remove this condition. Just checking to see if the old camera, the position is the same as the new one. I'm just gonna remove this. It's whatever. The problem is like this is only also it makes that equal to the cursor here. And maybe I should leave that. So it basically has this comparison between old camera and the new for interpolation, I think. So I think I can just change whenever I see camera cursor. I'm gonna remove this free look active thing. Probably. So it goes directly to the else. So I'm gonna replace with cursor here. So this is doing the interpolation between the old camera. So this is the question, do I put this or not? It might be easier to put this stuff. I think I'm gonna have to put Because it's also updating base, even though the camera cursor is going to be the same value. I think because it updates the camera cursor, it might. Like it's gonna update the cursor based on the events, and then it updates the camera cursor here. So I'm gonna leave the camera cursor. Yes. And then like maybe I'll remove later. So just for the sake of this, of being very similar, just gonna leave it like this. So maybe yeah, should just put stuff again. The values from the editor I'm just gonna replace. This is the one that I don't understand. Like, how is it possible? Because this zero should be drawing error there. I guess we'll see. Whatever. This is weird. That's because no event happened, so. But I think it's pretty much sure that this is all that I need there. Just gonna copy this function. Okay, now I think I have everything. So the set global transform should set the global transform of the camera, which is the global world coordinates, like global world, yeah, global world state overall, because the matrix 4 by 4. And it should be based on the camera, which is translated to transform 3D. Yeah, it's based on the cursor, which is translated to transform 3D by this function. So I think I did everything. I have to, the only thing is translating the values. Yeah, now it should be the same. So I'm gonna press F5 one more time. And let's press F5. Remove this. Yeah. So obviously there's a chance that I did something wrong there, but I think that the best thing to do is just try now, just see what happens. And if it doesn't work, then I'll just try. I'll just go over this again. But I'm gonna have to think. I'm gonna have to spend some time thinking about if it doesn't work, because I'm pretty sure that unless there's some mistake, like something that I forgot to translate or whatever, it should work the same way, I think. So I'm gonna try to compile on this one, and then test to see if it works. If it doesn't, go back to the thing. The only difference between the one that I have here and there, as far as I can tell right now, is that on this one I'm calling the events based on different events there. So calling the functions based on different events. But it should be the same thing. This is another difference, is what camera I'm using. So this might be something that breaks the thing. I'm gonna keep going here until I can test. Then after I test, I'm gonna stop streaming, then take a break, probably come back. But I wanna understand what the fuck's going on here. Oh, so it's considering this a templated thing, not a float. It must be because of the value. So this is the thing that is kind of weird. I'm just gonna put 0 here or whatever. Actually, let me just replace by 1 here. That's whatever. Because this is probably Like this is the part that is weird from the other one. But the other one has a variable just based on the editor settings that it's going to replace here, but the value is 0. So orbit inertia. So it's going to get a fraction of the delta from the thing, and it's going to compare if the fraction is smaller than 1, it's going to use the fraction. Otherwise, uses 1. So I'm just going to use 1 because it's 0 there, so I assume that's... But if it's 0, it should be like closer to... It's going to be bigger, obviously, than 1. It depends on the delta, actually. Because 1 divided by 0 doesn't make sense, but you should like converge to infinity. Multiply by delta is going to be infinity, so the minimum is going to be 1. I'm just going to replace this by 1. That's whatever. And let me see if I can compile. I forgot to change this, or to remove this. I think that's the only thing. Yeah, doesn't make any sense. So like it's complaining that it doesn't have the overloader function, but I'm doing exactly the way that they are doing there. Like this should be... So I'm just gonna change in the same way that I changed the other one. Because it's complaining about the type. Because the mathler only has float, 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 or double, double, no. And this is real t is supposed to be float, I think. Yeah, it's float. So this is gonna be 1 as well, because it's the minimum. So I'm just gonna put 1 here. And this is also 1. Actually, it depends on the delta, actually. So maybe... Yeah, but the problem is this minimum function is gonna get the... Because the minimum is a templated function, so it's gonna complain about the type. T2 equals that one. Oh, so it's because of the amount, the accuracy here. So I'm gonna put 0. I think that's what's going on there. Because it's translating the template to a double, and the other 2 values are floats, so it has to be floats. So I'm gonna try, but I think I removed there because it was casting the thing. Yeah. Just gonna do 50. So now it should work. Like, I don't understand because it's exactly the same. Oh, here's using math lerp and here is using, it's calling from the position. Hmm, that's why. Yeah, but that's really weird to me. Because why would it be working with the other? And the thing I can do is just get the delta there, but obviously the delta is gonna change, that's the problem. So I guess the only way is maybe I should use clamp instead of minimum. But I'm not really sure if clamp is gonna keep on the range. It's not the same thing. Maybe if I decrease minor. As it's saying this is a double. It's probably because of the accuracy of this. This should be a float, so let me put true here. It's whatever. Yeah, this is really fast and also has a inertia there. It's different than the editor. Okay, so panning is kind of weird because it's rotating. Zooming works, but is also fast. Damn, it works. Nice. So I think that the reason why, most likely the reason why it wasn't working the other way is because I wasn't updating with the physics probably. But I'm not 100% sure. Like it might be something like the only reasonable explanation is that is the way that I was updating the camera matrix. Because here, that's the main difference between the other approach and this one. Like here, I'm updating the values on the cursor, and then I'm using another cursor to uh, update the camera matrix. So it's like, it's updating the same state of the camera, but through different classes. And on the other one, I was updating directly on the class, directly on the camera matrix. But I'm not 100% sure why this doesn't work. If anyone's watching this and you have an idea, let me know. I'm curious about this, but I think it's unlikely that people are gonna know this. But maybe someone out there knows. But I'm pretty happy with this actually. This is exactly what I wanted. So the only thing that I'm gonna change is this zoom speed here, because there is a when I stop doing there is this inertia. So I'm gonna change those values of inertia there. But I'm pretty happy with this, to be honest. So I'm gonna stop streaming now. I'm not sure if I'm gonna come back. But I might come back. But if I come back, so I'm gonna think about what I'm gonna do. But either I'm going to spend more time trying to understand this, but to be honest, I'm not really sure if it's worth it because yeah, it is working fine. So I might just change the value there. And I think it's just easier to keep it like this because there's more important things to focus on. I want to get to the point where I'm actually building stuff and I already had to work on all this other stuff. So I want to get to that point faster. So the important thing that I want to do, I think before solving Barnsat, you should figure out like how can I change the visualization here so that like the colors are more, because the weird thing is that here, for example, is the red color, so it shows up one way here, but on the editor is a lot brighter. And I think the reason why is because of the lighting. So I want to understand how the environment works on Godot. But I might not stream this because I'm probably gonna watch a bunch of videos on YouTube of just the editor tutorials to understand how people usually set up the environment. Then once I have like a superficial understanding, I'm probably gonna go over the source code again, and I'm gonna build from the editor, I think, first to see. Maybe I'll stream today again to just build, just put different nodes on the editor here to see what happens with the visualization. But from the game's perspective, I want to get to a place where is like basically the same way here. Like the brightness of the colors and the background, everything, it looks exactly the same way here. And I want to do that first because I think it's going to make it easier to visualize after. And then right after this step, then I'm probably going to spend a bunch of time trying to implement Barnsat, which I think is going to be kind of annoying as well. So yeah, but that's the next big thing. Then after these shootings, then I need to integrate this stuff with the scene. And after I integrate manually, then I'm gonna go over, try to integrate everything from the code, build the entire scene from code, and set the names or everything so it is distinguishable. So I'm gonna have a template that I can build from code. Those are the next steps here. But I'm pretty happy with this, not gonna lie. So yeah, thankfully it worked. So I'm gonna stop here. I might not come back today. So if I don't, I'm just gonna keep doing this stuff like I said on the next streams. And off stream now, I'm going to watch tutorials and stuff like that to understand the environment better. And also fix this inertia here. So yeah, see you next time.